Today, we're diving into the hidden world of aviation, uncovering the invisible infrastructure that guides every single flight, acting as the true sentinels of the sky.
You know, it's a thought that crosses your mind, right? You're cruising along at 35,000 feet. You look out the window and there's nothing, just an endless sea of white clouds. So, how in the world does the pilot know where they're going without any landmarks? Well, the answer is this incredible hidden network of what are essentially invisible guides. They're called navigational aids, or NavAids for short. You can think of them as the unsung heroes of aviation, creating these invisible highways in the sky that every plane follows.
So, what exactly is a NavAid? Basically, it's any device, whether it's a transmitter sitting on a mountaintop or a satellite whizzing around in orbit, that sends out a signal to an aircraft. And those signals give pilots the critical info they need, their position, their course, and their altitude, especially when they literally can't see a thing outside.
Okay, so to really get our heads around how this all works, we're going to break it down. Let's start with the foundation, the original system, the ground-based network that, for decades, built those first highways in the sky. Let's talk about the VOR. That stands for VHF Omnidirectional Range. For a long, long time, this thing was the absolute workhorse of aviation. It literally shaped the map of the sky. The best way to picture it is like a lighthouse, but instead of a beam of light, it's broadcasting 360 separate radio beams, one for every single degree of a compass. The plane's equipment picks up these signals and tells the pilot exactly which magnetic line or radial they're on in relation to that station. So how does a pilot actually use this thing? It's a really elegant process, actually. They just tune in the frequency for that specific VOR, they listen for a quick little Morse code beep to make sure they've got the right one, and then they set their course. After that, it's all about keeping one little needle on their instrument perfectly centered. If it drifts left, they fly left. If it drifts right, they fly right. They are literally following an invisible line through the sky. And that right there is the whole idea. The entire country is crisscrossed with these VORs. Pilots just navigate by flying from one to the next, almost like they're hopping from one dot to the next on a connect the dots puzzle. These preset routes are actually called Victor Airways. Now, VORs weren't the only game in town. There were older systems like the NDB, the non-directional beacon, which was a bit simpler. It basically just acted like a homing device. And really importantly, there's DME, or distance measuring equipment. This is often paired with a VOR, and it answers the other huge question. It's not just which direction am I from the station, but also how far away am I? But here's the thing about ground-based systems. They're not perfect. They need a clear line of sight, which means a big mountain can get in the way and block the signal. And that limitation is what pushed us toward the next great leap in navigation, taking us from the ground all the way up into space. This was it. This was the absolute game changer, not just for aviation, but for all of us. Suddenly, instead of relying on a scattered network of ground stations, planes could tap into whole constellations of satellites that were blanketing the entire globe with incredibly precise navigation signals. So here's something important to know. Most of us just say GPS, right? But that's technically just the American system. The real, all-encompassing term is GNSS, which stands for Global Navigation Satellite System. That's the umbrella term for all of them: America's GPS, Europe's Galileo, Russia's GLONASS. By listening to the signals from multiple satellites at once, a plane can calculate its exact 3D position, latitude, longitude, and altitude, anywhere on the planet. And when you put these two systems side by side, you really see the leap forward. The old VOR network needed that direct line of sight, and it created these fixed, rigid airways. GPS, on the other hand, well, it offers global coverage, it's way more precise, and it lets pilots fly much more direct, fuel-efficient routes, because they're not chained to the locations of ground stations anymore. All right, so we've navigated all the way across the country using VORs and GPS. But now comes the most critical part of any flight: getting safely on the ground, especially when the weather's bad and you can't even see the runway. This requires a whole other specialized set of tools for, well, sticking the landing. For this, we turn to the ILS, or Instrument Landing System. Now, this is a ground-based system, but it's one that's all about extreme precision for just the last few miles of the flight. Its one and only job is to guide an airplane perfectly down to the runway, even if it's in the middle of dense fog, heavy rain, you name it. So how does it pull this off? Just picture two radio beams shooting out from the end of the runway. The first one is called the localizer. That's a horizontal beam that lines the plane up perfectly with the runway centerline.
The other one is the glide slope, and that's a vertical beam that creates the perfect, gentle descent angle. In the cockpit, the pilot just has to keep two needles centered, following that invisible pathway right down to the touchdown zone.
Now, all of this sounds incredibly advanced, and it is, but it also brings up a really important question about reliability. I mean, all these systems are electronic. What happens if one of them fails? That's where the whole idea of a resilient safety net comes in. And this is the big worry in modern aviation. We are incredibly reliant on satellite navigation now. But those signals are actually pretty weak. They can be disrupted, either on purpose, through jamming, or by totally natural events like a giant solar flare. What do you do then? This is exactly why redundancy is everything in aviation. Every single system has a weakness, which means it absolutely must have a backup. If GPS goes dark, pilots can fall back on that old VOR network, or even a totally self-contained system called an inertial navigation system, which is just a brilliant piece of engineering that uses gyroscopes to track the plane's movement with zero outside help. If a VOR station goes offline, they use GPS or just tune in a different VOR. There's always another layer. And this brings us to what might be the coolest part of this whole story. Old tech is our last line of defense. Even in this age of satellites, that VOR network is still absolutely vital. The FAA intentionally maintains a core set of these stations, and they call it the Minimum Operational Network, or MON. And its mission is simple. If every single satellite were to suddenly go dark tomorrow, this ground-based system would still be there, ensuring pilots can navigate safely anywhere in the country. When you step back, it's just an incredible evolution of technology. We went from simple blinking lights on the ground to entire constellations of satellites in orbit. But the fundamental goal has never, ever changed, knowing exactly where you are and exactly where you need to go. And that kind of leaves us with a final thought to chew on. We've built this amazing system of systems, this deep, multi-layered safety net. But as our technology gets even more advanced and our reliance on space gets even deeper, it really forces us to ask, what's the backup for our backup going to be? What will be the next sentinel of the sky?